Hello students. So I'm actually recording this video to help you on lab 0 and lab 1. Okay. So we have lab, we call it lab 0. It's actually it's 0 because it's not like a lab. It's just you install some software, as you will see right now. So the objectives of this lab, number one, you need to complete the lab safety training, because this is required by Tech. Okay, this is the first part. Second part, to install and be familiar with the software we are going to use in the coming labs. So for the first part here, you need to follow the instruction we have here. Okay, and to do the training, safety training. It's not allowed to do labs before doing this training. Okay, so it's required by Tech to do this training. If you don't do it, you can do any lab in this course. Okay, but don't forget to take a screenshot of the safety transcript, because this will you need to submit it with the report of this lab. Okay, so this is the first part. In the second part here, you need to install digital tool, this one here. So actually, digital tool, this one is actually a simulator, as you will see. It's a simulator for logic circuits. Okay, it's very interesting tool because you can actually draw any logic circuit, and then you can see the input, the output. Okay, so it's very. So here I give you the details. How can you download it? And we will use it in the coming labs. Okay, but again, this is just simulator. Okay. Number 4, you need to download the software that we are going to use it with analog. Okay, let me tell you here. With the analog discovery kit I told you about. So let's explain. I told you in the lecture and also by several emails, when you need two things. Number one, you have to go to the department and you have to check out the analog discovery kit too. Okay, you need to check it out, and by the end of the semester you have to return it back. You don't need to pay any money for this one. Number 2, you need to get digital kit. Okay, this digital kit has it chips, it has connectors, it has wires, everything you need in the coming labs. Okay, but for this one here, so let's explain. This is very interesting. It's very important. So this one actually it can work. It can do actually 3 things. Okay. Number 1, it can act as a function generator. Okay. So you can use it as a function generator. So what function generator means? Very simple. So function generator is actually a device. Okay. This device can generate signals. So you can adjust it to generate sine waves. For sure, in this course, you are not going to see any analog signals. You are going to see 0 and 1s. Okay, but in general, function generator can be used to generate any signal. But in this course, because this is a digital course, we are gonna generate digital circuits. Digital signals. Okay, so so in this, digital means 0 and 1. So all the circuits we are going to explain, they work on 0 and 1s. Okay, so I want you to understand, we have here for 0 and 1. So 0 logic. So this is logic 0, and this is logic 1. So logic 0 is usually in the range between 0 volt to something like 0.2 or 0.3 volts, something like that. Okay, so you can get the exact number from the chip. So every chip may be a little bit different, but anyway, so it's 0 or very close to some. Any volt that's very close to 0 is going to be taken as logic 0. Logic 1, usually it is in the range of 5 volt, but also it has a certain range, maybe 4.5 to 5, something like that. That's why in this course, that's what I told you. That's why in this course we are interested to generate a square. We generate digital signals this way, which is between 0 volt and 5 volt. Okay, so here in 5 volts is logic 1, logic 0, logic 1, logic 0, logic 1, and so on. All the time we will do that in this course. But in general, function generator can generate different types of signals. But in this course, we are going to be interested in only in digital. But in general, this kit can act as a function generator. This is number one. Okay. Number two, the same kit, the same analog discovery kit, it can act as a scope. So what is a scope? Very simple. Scope is, so let me make a space here. Here is scope, or sometimes we call it oscilloscope. Okay, anyway. So it is actually a device. This device has a screen this way, okay, and then you can connect this device to, you have a circuit here, you can connect to the circuit, and then it can visualize the signal we have here, okay, whatever the signal is, okay. So if the signal is a square wave, it's going to display. So this one, so function generator, you can tell from the English name generator, this one is used to generate signal and use it as input, sorry, to generate signal and use it as input to the circuit, okay. If I want to see the output, that's what the scope is, okay. So here, this one also can act as a scope, okay. In this scope, you have here units. This unit is the time, and then you have here unit, which is the voltage. So it can display the voltage function in the time, okay. So this is also one thing we're going to use this one. So very simple. So this discovery kit can be used like a function generator in order to generate some signals, and then these signals are going to be input. Sorry, to generate some signals, and these signals are going to be, we're going to use them as input to the circuits. Okay, we're going to do in this course. This number one. Number two, I can use it as a scope. Okay, a scope means if I have a circuit, and then like this is a chip, and the output here of the chip is here, I want to display the signal here, so I can connect this one here and see how the signal looks like. Okay. Number three, it can also used as a power supply. Okay. So what this means, it's the same kit. Okay. What it means, so in this course, we are going to use a lot of ICs, or chips. So these chips, to use any chip, as I'm going to explain, you need power supply this chip. Okay, usually one pin should be ground, 0 volt, and one pin should be 5 volt. Is that okay? So how can I get 5 volt and 0 volt? This is also can be from the kit here, power supply. Okay. So that's why this kit is very important. And this kit actually doesn't have a screen. You need to connect, the screen is going to be your laptop. So you need to connect it to your laptop. Once you connect your laptop, you can see the signal on, and you need to download this program. Okay, so this chip does not have, um, um, you connect it using a USB. USB is a small USB. I don't know what's the name of it, but you have, from one side it's a very, we use it all the time. I don't. Oh yeah, USB C. I think C from one side, and then the normal USB on the other side to connect it to your computer. Anyway, okay. And you can control it. You can control this one from your computer. So if you want to generate any signal, it's going to be from your computer. So to do that, you need to download this software. Yeah, this program. That's what I'm going to explain. That's what I'm explaining here. You need to download this program, because this is the program that's going to connect to the kit you have, and then using this program, you can see the signals. You can select what the signal you want to generate, and so on. Okay. These are what you have to deliver. So you have to upload, you have to make a report, and for report we need from, as I told you before, every two students should work in one group, and we need only one report, okay, from each two student, but you have to upload the same report twice to, so every student, so now one group Okay, we need only one report. However, every student in this group has to upload the same report so that you can see the correction, because the TE is going to do some correction on your report. Also, you can see the grade, your grade. Okay, so again, every group has to make only one report. Okay, and but this report has to be uploaded twice by the two students. Okay, we're going to grade it only one time, so make sure it's exactly same report. Okay. So this is so this lab is out of 15, as you see here. And yeah, so here this is just, you need to see I ask you just to prove to me or to take some pictures for what you have done here regarding the simulator, or to regarding the training, okay, training, and also regarding um, the discovery, the software for discovery, okay? So this is everything you should do it before coming to the lab. So you have to do this one, the installation, before you come to the lab. This is a pre-lab, okay? The second thing here, this is lab number 1, okay? So the objective of this lab has two objectives. Number 1, to become more familiar with the use of oscilloscope or function generator of discovery kit 2. So the first part here, I want you to be familiar with the program. Okay, you already downloaded here for the discovery kit. Okay, this first part. The second part here, we're gonna start using a chip for logic circuit. We call it inverter. Okay, or we call it not gate. So this is how the symbol of this one. So it has only one input, it has one output. Okay. So this logic circuit is actually inverter. You can tell from the English name. So if the input here is logic 0, it's going to give you logic 1. If the input is logic 1, you are going to get here logic 0. Okay. I told you everything I teach here in this course, it has electronics background. Okay. But for sure we're not gonna teach electronics in this course. But I'm gonna just use the symbol this way. Okay, so I have a symbol. Sorry, I have a circuit. This circuit, it should work this way. Okay, give you 0, give you 1. Give it 1, you get 0. Okay, but how it works is the electronic behind it. This is out of the scope of this course. For example, just give you example. This one actually simply can be made using transistor, any kind of transistor. Okay, this way, for example, here, and the output is here. Okay, this is a very simple way to do it. For example, if I input here and here we have 5 volt here. If I put here 0 volt, so the transistor is off, open circuit, and the output here will be very similar to this one. Is going to be 5 volt, which is high. So if I input 0 volt, I'm going to get 5 volt high. Okay. If I put here 5 volt, okay, this one becomes like a short circuit. And here I'm going to get 0 volts. The current is going to go this way. And this one, it becomes 0 volt. So when you input 5 volt, you get 0 volt. Anyway, forget the electronic I explained, but I just want to tell you for every gate I'm going to teach in this course, it has electronic circuits that can implement the functionality. But we don't care about it. We only use it like logic circuit, because this should be, you can learn it in any electronic course. Okay. So now the second part here, we're gonna use a chip. Okay, this chip has number of inverters, and then you will learn how can you use it. Okay. So let's start with the first one here. So this lab has two parts. The first part here is how can you use a discovery kit 2 as for scope and function generator as well. So here I give you some background about here. That's what I've just explained. So function generator here, function generator can produce a periodic signal. That's what I told you. Here it's called periodic train of pulses. So again, this signal can be analog, like something like that. It can be digital, something like that. But again, in this course, we're going to focus only on the digital, okay? And then you need to know something here about, for example, here, if you have, okay, if you have a signal like this one, guys, okay, this is a periodic signal, okay? So actually here, for example, 0 volt, and this is 5 volt. So the time from here to here, we call it the period, okay? From here to here. the time is interval. This is the interval time or the period. Okay, you know the frequency is just 1/t. If you flip this time, it gives you the frequency. Okay, so that means the smaller this time, the higher the frequency. So this is the first thing you need to know. If you have a signal, what is frequency, what is the period or the interval of this of, there's also something important we're going to teach. We need to know something called duty cycle and also amplitude. So I'm gonna explain here. So so what is the duty cycle? I'm gonna tell you what is the duty cycle. Simply, the duty cycle is this time from here to here, the time of the high 5 volt. I'm gonna call it T on. Okay, so the time of the high is T on. The total period is T. So if you divide T on divided by T, this is what we call duty cycle. The ratio, how big is T on comparing to T. You can tell this ratio should be between 0 and 1. Maximum is 1. For example, like if you example, so if the signal is something like that, so I can say the duty cycle is, for example, 10%. So this part here is, for example, just 10% of this part, for example, okay? Or if the on part is big one, something like that. So in this case, this duty cycle can be 90%, because 90% means 90% of the cycle here, of this cycle of this period from here to here is high. 90% it is high. So this is something we call duty cycle. So usually in digital we use 50% duty cycle. 50% means the time for the on is equal to the time of off, or the time of this on is half of this time. So this time here of on is t divided by 2, and this one t divided by 2. So usually, but because we're going to use this term a lot, duty cycle, but usually I don't see any reason here in this course to change the duty cycle. So it's usually 50%. Okay, maybe in other courses on other things, but not in this course. So I'm going to talk about the amplitude shortly. So here I'm just explaining. This one should generate a square wave, right? This one can analog or digital. The scope is used to display and analyze your signal. One of the good thing here, we have multiple channels. So what do you mean by multiple channel? Multiple channel means, so for example, this is the discovery kit. I can use this one as a channel 1. I can use a channel 2. Maybe you have more than 2 channels. Okay. So every channel can display one signal. So that means it is possible on the screen of the discovery kit, you can see multiple signals. Okay, so you can see multiple signals this way. Okay? For sure, again, we're gonna focus on square waves in this course. So, for example, here, if you have an inverter, if I apply an input this way, so the output has to be this way because it's inverter. So I can display both of them at the same time. So here I can see this is the output. I can see the input this way. So I can, because we have multiple channel, every channel can show me one signal on the screen. So I can display more than one signal at the same time. Okay, so here a multiple channel can be used. So here this is the chip you are going to use. So now that's why where you can find this chip. You can find this chip in the digital kit you have to buy. Okay, so the digital kit should have multiple chips. Also, it should have a breadboard, something like that. So I'm going to explain now how can you connect the chip here. But okay. Anyway, so let's, for example, here I just want to talk here about something we call it offset and amplitude. Offset and amplitude. What do you mean by offset and what do you mean by amplitude? Okay. And here, so here we have analog notation. So first of all, offset means you shift the signal up or down. That's the meaning of offset. So for example, if I have a signal this way, okay, if I add an offset of 2 volt, we have 2 volt this way, so you shifted it up, you can shift it down. That's what we call offset. Okay, this is the meaning of offset. Um, So now I'm gonna come to amplitude. So what do you mean by amplitude? As you know, for example, in analog, if you have an analog signal, something like this one here, this one is called amplitude. From here, the voltage here, from here, amplitude, and then we have another amplitude here, and they are equal. So this is 3 volts, this is 3 volts, they are equal. Okay. But in digital circuit, because we're not going to have something like that. Usually in digital circuit, guys, we have 0 and 1, which is, for example, 5 volt and 0 volt. We have something like that all the time. Okay. So what happens here is this is the amplitude from here to here. And usually, as I told you, I don't see any reason to change it in this course. Usually, I want to generate a signal as 0 or 1. That's what we only use, 0 or 1. So 0 means 0 volt, 1 means 5 volts. So usually, we're going to use 5 volt in this course. Okay. So what I'm saying here, if in case of analog, we have different notation or different in case of analog, because you can this one is amplitude, this one is amplitude, and then you can shift the signal up or down. You can do that. But here, usually what we're in digital, the amplitude is from here to here, and usually it's 0 and 5, as I told you. Uh, and even we're not going to go to -2 usually. Usually it's at 0. Okay. Um, but the thing here, and that's what you should see, the thing is that when you use the device, when you use that discovery kit here, for example, I said when you set the when you select the numbers here, for example, I can say 2 volt, and the amplitude here from here to here is actually 4. So if you select the amplitude of 4 and 2 volt, so it's going to be something like that, shifted at 2, okay, and 4 up and 4 down, okay. This is in case of analog notation. Uh, if I want to generate in case of digital notation, offset usually has to be 0, and then amplitude should be 5. But anyway, if you want to use analog notation, but you want to generate digital signal, what you have to make sure is, okay, so I have to make sure it has to be here 5 volt, and it has to be 0 volt here. Is that okay? 0 volt has to be something like that. Okay. So in this case, I have to ask the device to make the offset 2.5, because if the offset here 2.5, and then the amplitude from here to here is 2.5. Okay, is that right? Yeah, 2.5 up and down. So if you ask amplitude to be 2.5 and offset 2.5, and you are using analog notation, you are going to get digital signal like this one, which is between 0 and 5. Anyway, so here in the first part 1 here, I ask you, you have discovery kit, okay? So I want you to generate a signal. You generate a signal here so that you can learn how can you use the discovery kit to as function generator. Yeah, this is the first part. And then yeah, I will ask you to connect the signal you generated from the discovery kit to another input here. So this is output, but I'm going to connect it to an input for the scope so that you can see it on the screen. Okay. So now you will learn here in this course how can you generate signal using function the discovery kit, and also how can you display it or use the discovery kit as a function generator. Okay. So anyway, so here I give you some instruction. You need to create 1 megahertz, 25% duty cycle, rectangular because it's 25%. That means this one here should be one quarter of the total. So it should look like something like that. So this one is 3 times this one. Anyway. So anyway, I give you some instruction. How can you do that? And I give you specifics. So you have to go to this menu. You have to select this one. You select this one. Again, the objective here is to learn how can you generate signals so that in the future, even in also in this lab and also in the coming lab, I want to generate a digital signal. Then I'm going to connect it to one gate, whatever it is, AND gate or invert or whatever the gate is, and then I want to see the output. Okay, so the first part here is about mainly is about how can you generate signal. Okay, so here I give you also more instruction. You have to select square. The type of the signal is square. When you go to frequency, you have to make it 1 megahertz. When you select amplitude, you have to select it +2, select offset of +3, okay? And then I give you other things here to select, okay? If after you select that, and then you have to press this button. So I give you very detailed instructions here. How can you generate signal? So this is the first part. Once you generate signal, now I'm gonna talk about how can you use the scope, and how you need to connect them together so that the signal I generated here, I wanna see it on the scope. Okay. So that's what I'm explaining here. But here the offset is 3, so I'm gonna go up 3. The offset is 3, and then you are gonna select amplitude of 2. So it should be 2 means it's gonna go to 5, right? 2 plus 3 is 5, and then it's gonna go to 1. Okay, anyway, something like that. Anyway, you just need to learn how can you generate signals. Okay. The second part here, I'm asking you, there is a channel 1. I told you we have different channels because every channel can display one signal. I can display multiple signals together. Okay. One of the important things here that you need to know is, as I told you, this is the screen here. The screen has, okay, the y-axis here is the voltage. It's always voltage. X-axis here is the time. X-axis here is the time. So here we have units here, units. So this units is actually, look here, something like that. How many nanosecond or microsecond per division or per unit, okay? Here, same thing. So here we have here, how many voltage per unit, okay? So here, so two things you need to select. One related to y-axis, one related to x-axis. The one that's related to x-axis should give you how many, every unit here, how many seconds per unit or per division. Here, how many voltage per division, okay? You need to, for example, here, 2 volt per division. So every division is 2 volt, okay? So, by the way, so these are parameters you can change in the program. Once you change it, you can actually zoom in or you zoom out, okay? For example, if I say 2 volt per division, okay, so here this is 2 volt and this is 2 volt. So for example, if the signal goes this way, it's going to be 4 volt, 2 and 2, right? But if I make this one, for example, 4 volt per division, you will see something like that. Okay, so it's going to zoom in or zoom out because it's like you maximize or minimize, okay, on the screen. Okay, so try to maximize the signal so that you can see it better when you do measurement is better. Okay, so for example, if you have something like that, for sure, if I have a signal like this one may be very difficult to do the measurement. Even the error may be too high. So try to get the maximum out of it so that try to get the maximum you can get from the signal so that you can measure it. So you can control that. You can control the voltage using this one because this is something you can select. So you can select when you display how many voltage you want to display per division. Or same thing for the time. For the time is gonna be, or the signal is, if it is small, so you can see too many signals this way. If it is small, but if it is big, you can see only one here. So you can control that x-axis. This one is x-axis, and this one is actually y-axis. Okay? You will see and you will do it, but usually what we do when we use the scope is we change these values until we see very clear signal, until the signal becomes very easy. For example, if I want to measure something like that, so yeah, I make it maximum so that it's easy for me to measure. So here I give you details. How can you do that? I give you here, even I'm telling you about which wire you have to use for channel 1. Okay. Later in this course, you will see how can you use more than one channel. It's very easy. It's almost the same way. So now I'm telling you, you need to connect. So now what I did here, using Discovery Kit, I generated the signal, and then I have another signal here. I have to connect. Sorry, I have here the scope. So I need to connect it here so that I see the signal here. Also, you need to connect the ground. So I'm giving you some details about what you have to do. Okay. Again, the objective of this part is to learn, number one, how can you use the function generator with the discovery kit so that you can generate signals in the future. Number two, how can you use the scope to see signal, to see a signal. Okay. So anyway, I give you a lot of details here. You need to know all of that because all the time we are going to generate signals. We are going to also display signals. Okay. So anyway, so I give you here what you have to do. Everything should be easy in details. Okay. Now we're going to move to the second part. The second part here, we're going to use 74. As I told you, we have different chips. You can find these chips in the discovery kit. The first chip we're going to use, 74 is a family. 74H is a family. This family has different chips. Each chip has different component. Okay. So the first chip here we are going to use 04. 04. So 04 is actually, I have the picture here for this family. Yeah. So this is the chip. Okay. So 74H04. Okay. So this is a family. This family has different numbers. For 04, this is the how the chip looks like. Okay, so this is chip. It has 14 pins. Okay, and pin number 14 has to be connected to VCC, which is usually 5 volt. Pin number 7 has to be ground. So if you don't do that, the chip cannot be used. You cannot use the chip. Is that okay? So all the chips you have to connect whatever the pin. Usually, I think for most of them it's going to be pin number 7, but you need to check anyway. So one pin has to be connected to the ground. One pin has to be connected to 5 volt. Okay, and then this ground and fault should come also from the discovery kit. And then after that, as you see here, pin number 1 is so this chip has 6 inverters, as you see here, 6 inverters. So if you input from number 1, the output, if you don't need to use all of them at the same time. Okay, maybe I need only in this lab we need only one. Okay, so you can use any one of them, doesn't matter. Okay, so for any one of them here I give you so here for this chip, this pin number 1, pin number 2, pin number 3, 4 until 7, and this is 8, 9, 10, and so on. Okay. So one of the questions and one of the important things is given the chip, how can you know the numbers? How can you locate these numbers? I'm going to tell you how. Usually for the chip, sometimes you have something like that, okay, in the chip. So this means this is going to tell you have to start counting from here, and it has to be this is counterclockwise, right? So it has to be counterclockwise. Okay. So usually in the chip you will see something like that to indicate to you you have to start counting from here, and then you have to count this way counterclockwise. Okay. So here I give you one of the important things here, guys. If you see something underlined here and this way, you know this is hyperlink. If you click on this hyperlink, you will go and get the data sheet. Okay, it's highly recommended for any device working or for any chip we're going to use. It's highly recommended to use to look at the data sheet. So the data sheet is going to explain. So this one here is coming from the data sheet. It's just a PDF file. You have to open this PDF file. It's going to give you the structure of this chip. Also, it's going to give you some interesting information you need to know. Okay, so I'm going to try to go through some of this information, but I want you to also to just take a look at the data sheet. Very, very important thing. Okay, so here here it gives you some information about supply voltage VCC. Okay, give you some range for it. But as I told you, we are going to use 0 and 5 volt. Okay, maybe you don't maybe you don't need all this information. Give you about the power dissipation. Okay, how much power dissipation here. So I'll give you some information about the temperature here. Okay, but anyway, so you may not need all of this information, but it gives you some useful operating temperature. For example, this one can work between 0 minus 40 to positive 85 Celsius. 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 Okay. Anyway, so one of also the important things is, because this is something you are going to measure in this lab, is what we call TR and TF, rise time and fall time, rise input rise time and fall times. Okay, I'm going to tell you what this means. Okay, so I'm going to tell you, ideally, any signal, any digital signal has to be something like that. This is 0, 1, or 0 volt, logic 0, which is 0 volt, or logic 1, which is 5 volt. Ideally, it has to be like that. But in reality, nothing in the world can change it from 0 to 5 volt in 0 second. It cannot happen. So in reality, there is some rise time, okay, and there are fall time, okay. So there is some time to rise, some time to fall this way, okay. So here it gives you some information about the rise time and fall time at different VCC values. So it can be, for sure, this is a very short time. We are talking about nanosecond, right? Or 400 nanosecond, very short time. Also here I give you some information about P input high. P input high is the minimum voltage that can be taken as input. Minimum voltage that is at the input. So if you have inverter here, okay. So what is the minimum voltage I have to enter here to be counted as logic as high? Okay. So here again, this value depends on several things. So it depends on the, I think, on the temperature. Also, it depends on VCC. What is the value of VCC? Usually, we are going to use isotopes 5 volt VCC. So it's going to be something here. Okay, so we're going to take 4.5, for example. So here in this case, so here is the minimum value for high. It's going to be something like 3.15. So from 1.5 until 5 volt, all this range, any volt, but this is the minimum, okay? Any volt in this range is going to be counted as logic 1 high, okay? Same thing we have here, the input low, okay? This is the maximum values that can be counted as low, as logic 0. Okay, for example, if also you do the same thing, so it's going to be 1.35. So any voltage that's 1.35 until 0 volt, anything here will be taken as logic 0. Okay, anything here will be taken as logic 1. What about the area here? For sure, this is undefined. You should not work in this area, because if you are in this area, the device is not going to act correctly. Okay, so always, if it is high, if it is logic 1, you have to be in this range. If it is logic 0, you have to be in this range. Okay, so now one of the important things also here you can see in the data sheet. For sure, I can't explain everything in the data sheet, but I want you to dig more in the data sheet. So one of the things here is V output high and V output low. So these two are for the input. Okay, these two for the output. Okay, for the output of the inverter. Okay, so the output here is actually the minimum high it's gonna get at the output here. For example, I'm gonna use this one here is gonna, so the high here is gonna be 4.4. The high here is gonna be 4.4. Same thing for the low. When the output is low, so it's going to be 0.1. So the output here is going to be 0.1, okay, for low. Okay, but no, this is I'm not saying it's going to be exactly, but this is the maximum output you can get. So you can get less than that. Okay. Um. Yeah. Here I talk about maximum current and other things. Anyway. So I want you to look at the data sheet, okay, because it's very important. So what we have to do here in this lab is, number one, you have we are going to use one chip of this one. So the way you have to connect, as I told you guys, yeah. So here you have to put the chip this way. First of all, I can tell you something quickly about this one. It's called the breadboard. Okay. This breadboard is used to make a circuit. I'm not sure if you used it before, but I'm going to give you some basic information about it. Number one, all these lines here are connected together internally. Okay, so this point and this point is actually one point, because internally it's a short circuit. Same thing here. This one is short circuit. This one is short circuit internally. Okay, this is one thing. The other thing here, this gap is used just to connect the chips this way. Here, usually you put the power supply here, either +5 and 0 here, okay? But these ones here are connected this way. So all of this just short circuit. So usually what we do is, same thing here. So any one of them, you can use any one of them. So usually what we do is when we use the breadboard is we're going to connect this one here to 5 volt. So that means all of these ones are 5 volt. I'm going to connect this one to ground or 0. So all of this one is 0. And then I connect, I'll put the chip here. If I want to get 0, so yeah, I'm going to connect a wire from here to here. Here, if I want to get positive, so because I told you this is, for example, pin number 14. Okay, so all of these are connected together, so I can take any one of them, short circuit, right? So I connect the wire from here to here this way. Okay, and then the input, for example, if I want to use this um if I want to use, let me go here. If I want to use, for example, this one here, yeah, for example, here, this one here, so pin 1 and pin 2, okay? So what I'm going to do here is I have to connect pin 1, I have to connect it to the discovery kit, okay? But because this is input, I have to connect to the function generator to generate signal this way, and then the output will be from here, so this one has to go to the scope, okay? The discovery kit. By this way, I'm going to use one inverter here, but keep in mind, guys, very important, you have to make sure you have to connect ground and you have to connect VCC, which is 5 volt, to be able to use any inverter here. Okay, so if you don't do that, none of these transistors are going to work. Okay? That's a biasing, or the voltage that needs for the transistor to work anyway. So here I give you some information about what you have to do. Here, the analog discovery kit has 2 power supplies. So here I'm telling you about the power supplies, because this power supplies, this one needs power supplies. I told you 0 volt ground and 5 volt for PCC. So this power supply also is gonna come from the discovery kit. Okay, so here I told you change the voltage for the first power supply to 5 volt. Okay, power the circuit by clicking whatever. So I give you some instruction about it. Now I connected channel 1. I'm going to use channel 1 for the scope. Okay, and here for of the scope, the output of the and the outputs also, I'm going to use the output of the wave generator. As I told you, I'm going to use signal generator or function, sometimes it's called wave generator, signal generator, function generator, whatever you want to call it. So here also you are going to use pin number 1 here, so that you are going to generate a signal. Here I ask you to generate a signal that's 1 kHz. This is a frequency. I ask you to make the offset of 0 and amplitude of 5. Okay, because here you selected square wave. Okay, since the analog whatever, so here I give you some information here. So here I'm telling you, if you want to use the analog, so you have to make the offset 2.5, positive 2.5, and then the amplitude 2.5. If you do this way, I'm gonna get 0 and 1. So here's gonna be 2.5 and then 2.5 up, 2.50, 2.5 down. So it's gonna be 0 and 5 volt. Anyway, at the end, and also always in this course, guys, don't even think about it. Always in this course, we use digital signals, which are between 0 and 5. Okay, so and then here I ask you to connect the channel 2 on the scope. Okay, I connect the channel to the inverter. Okay, and then anyway, so here I ask you to select second per division. Okay, then I ask you to draw one important thing here, guys. Also here I ask you to sketch the signal you see, but also it's highly recommended, or what it's actually required. Also, you need to take screenshots from everything you do and put it in the report. Okay, so here also here you need to change this division, volt per division. So you zoom in and zoom out, as I told you before, so that you can see the rise time and the fall time I told you about. Okay, so ideally, if you zoom out, you will see something like this. This is the input and this is the output. Okay, you should see something like that. Okay, but if you zoom in and you see in reality, it should not be this way. In reality, it should be this way. Okay, and then the other one is going to be shifted this way. Okay, so there is some time for rise, some time for fall, sometimes for fall, sometimes for rise. Not only that, there is a shift, which is we call it a delay. Don't think once this one is high, the device in 0 seconds is going to be low this way. No, that's not true. What happens is that there is a delay. Okay, the device takes some time, okay, to act, to open the transistor, close the transistor, so it takes some time. That's why there is a delay. Okay, so you should see delay. Okay, this is like ideally, or ideally case. But anyway, so here I align the rise time of the output. So here I give you something you need to measure and record the rise time. Okay, sketch whatever. Also here, measure and record the full time, rise time and full time, and so on. Okay. So yeah, this is what I told you about it. So here, you need to connect the function generator. You need to connect the scope here. Yeah. Yeah, actually, this is, I think I told you to measure the time here between 1.5 and between 3.5, because here, yeah, it's gonna between 1.5 and between 3.5. This time, rise or fall. How much time is gonna take to rise? How much time to fall? But actually, in reality, okay, this figure is really very important, because that's what really happened in reality. In ideally, it has to be this way, as I told you before. Okay? So in reality, it's not like that. In reality, it has to take some time to rise. Also, it has to take some time to fall. Okay, and usually, the full time, for the fall and for the rise, we take it actually between 10% to 90%. This is just a definition. Okay, so the rise time is actually the time is taken for the signal to increase from 10% to 90%. The full time, the fall, okay, is actually the time for the signal to drop from 90%, okay, of the maximum value until 10%. So usually this is something like standard. Usually rise time or fall time, usually we take it between 10 and 50. Okay. So there's also something I told you about, which we call it a delay. There is a delay. Okay. So if you apply a signal, don't think it's the opposite. There's some delay here, some delay. Okay. This is something natural, because simply because a transistor takes some time to open, close, something like that. So here, to measure the delay, usually what to do, I think in the coming lab we will do this in details, but just here to explain everything here. So actually what happens here in the delay, here, this is, we take 50% from here and 50% from here. Okay, this is the time here. This is TP. TP means the delay time from high to low. When the signal moves from high to low, high to low, high to low, this is the delay time. Okay, we also have a delay time when the signal moves from low to high, and they don't need to be equal. Okay, sometimes they are different. Okay, so here we have two delays. So if you see, this is 50%, but this is 50%. It's not exactly at the same time. They are not aligned. Same thing here. Okay, but those is just definitions anyway. So you need here to do demonstration. So you need to show the things during the lab. Show it to the TA. The other thing is here, there we have some post-lab question. You need to answer this question. You have to include it in your report. More importantly, these are the deliverable, deliverable. You have to actually, your report has to have these things, because this is how we will grade it. Okay. So let's go through this question quickly. So the first question, how can you know pin number, the pins? Okay, so I already told you, usually if there is something here, you need to count the pins this way. Okay, here define what is the rise time, describe how it is measured for the chip, and give the particular value you measured. That's easy. Same thing for the full time here. That's easy. What factors in a circuit that can affect the rise and fall times? Okay, this is a very good question. What factors in a circuit that can... Okay, so the main idea here, one of the things that can affect the rise or fall time is, if you have here, for example, if you have an inverter this way, okay, and now you connect a wire, this way to measure it, so the rise and fall time. Okay, so Same thing here also, there are some wires. These wires actually has a capacitance, okay? So these wires usually has capacitance. So this capacitance also has some control on the rise time and fall time. I think temperature also is a factor, okay? So if you go to the data sheet, I think temperature for sure is one of the factors. Um, yeah, look here, it's very shown here. If you see the data sheet here, you can see the rise time. Yeah, the input rise time and fall time is gonna also depend on the temperature, also depend on the value of VCC. So it can be different, all of that. Okay, but if any external effect is coming from wires, so wire actually has a capacitance. The higher the capacitance, this can has impact on the rise and fall time. Anyway. So the last one here, what is the amplitude and offset? So here I just give you a question. If I select amplitude and offset of a rectangular signal with this one and ask you to draw it using the analog and digital usage. So I don't want to be confused, but yeah, if you see here in this case, so in case of use the analog notation, so offset means this is the value in the middle here. Amplitude means what is up and what is down. Okay. But here in digital notation, okay, this is the amplitude is here, and then the offset is gonna be you offset the whole square wave. So you have a square wave this way, and then you offset everything up or everything down. Okay, so you can see the difference between them. So I think this question I ask you to use the digital and analog notation. Okay, thanks guys and good luck.